Cinrad high-performance CO2 lasers are available across a wide range of performance specifications, allowing them to be optimized to meet your specific application needs. There are a few key factors to consider when designing a CO2 laser processing system, including laser performance specifications, beam delivery, and external requirements like cooling. There are three primary specifications to consider when selecting a laser: power level, wavelength, and pulsed or continuous wave operation. Laser power is a measure of average output wattage. Generally, higher power lasers will allow higher processing speeds and the ability to cut thicker materials. Cinrad lasers range from 5 to 500 watts, covering a wide variety of applications from marking small barcodes to high-speed cutting and converting. CO2 lasers are available in different wavelengths, commonly 9.3, 10.2, and 10.6 microns. When the wavelength is matched to the target material's absorption characteristics, results are typically higher quality and the application can be processed at higher speeds. Finally, the laser can be either pulsed or continuous wave. Pulsed lasers produce a series of pulses at high peak power. This delivers energy more efficiently and can reduce heat affected zone, penetrate thin materials more quickly, or pierce challenging materials like metals. In contrast, continuous wave, or CW lasers, can emit a continuous beam of light. These lasers are useful for marking, engraving, and creating smooth cut edges on materials like acrylic. Cinrad application engineers can perform sample material testing at facilities in the US, Germany, or China to help customers with this selection process. After selecting the proper laser, there are several ways to deliver the laser beam to the material. The best solution will depend on the application requirements, including throughput speed, material thickness, and material size. Scan heads use galvanometer mirrors to quickly steer the laser beam across a material. 2D scan heads are often used to create small detailed marks, while 3D scan heads incorporate a third, Z-axis, to allow fine processing across a wider field of view. Cinrad scan heads are available in both options and are pre-aligned for quick plug-and-play use. XY solutions use a combination of X and Y motion to steer a focused laser beam across a material. Examples include gantries with flying optics or gantry-mounted lasers. These systems are typically slower than scan heads but can cover a larger workspace, provide coaxial air assist, and their focus spot size can be easily optimized to the application. Fixed focus solutions mean that the distance between the laser and the material is fixed, while the material itself is moving. This can be a roll-to-roll system, moving stages, or robotic motion. Remember that Cinrad's application experts can recommend an optimal setup based on your application needs. To complete the laser processing system, a few external requirements should be considered, including air versus water cooling and electrical power supply requirements. Cinrad lasers 100 watts and below are available in both air and water-cooled varieties, while higher-powered lasers require water cooling. Both the output wattage and your operating environment will determine whether the laser should be air or water-cooled. For best operating results, a line of perfectly matched Cinrad power supplies are available to pair with our lasers. More information is available in the Laser Operating Manual. There are many factors to consider when designing a laser processing system, including laser parameters, beam delivery, and external requirements. Remember to determine your desired results, including the material, throughput speed, and expected quality. With this, Cinrad application engineers can provide material testing to identify the optimal CO2 laser processing equipment for your specific application.